And we are back with part 2 of LFR2, determining and interpreting intercepts. So we've done the determining part, we've also done the graphing part, but now we need to do what I consider to be the most important part here, and that's the interpretation. What do these actually mean, all right? So let's go ahead and take a look at this. This is explained to, if you're looking at the bottom, the page number is 213. We're gonna start at the top though, because that's what we do most of the time. So it says you can use intercepts to interpret a situation that is modeled by a linear function. Linear, keyword in there, linear. It's that whole line business, right? And function. Keep this in mind for just a second because we're going to talk about that. Yes, we are. Example 2, find and interpret. So there's 2 parts. The X and Y intercepts for each situation. We have the Sandia Park tramway in Albuquerque, New Mexico, travels a distance of about 4,500 meters to the top of Sandia Peak. Its speed is 300 meters per minute. The function f of x, f of x, we'll come back to that. F of x equals 4,500 minus 300x gives the tram's distance in meters from the top of the peak after x minutes. We're told what x is. Y, well, we don't see a Y. There's no Y in this. How are we supposed to figure out? Because, you know, we saw it set Y to 0 and solve for X, right? Or solve for Y. There's no Y. Function. If you remember function sometimes has a notation. Function notation, f of x. F of x. F of x just indicates Y. So when you see f of x, you could also replace that with y. That also means y. It's the output of the function. And the output of the function in this case is going to be distance from the peak. Let's take a look at this business here. So to find the x-intercept, just again, step 1 and step 2. Okay? So find and interpret. We're going to find it first. To find the x-intercept, replace f of x or y with 0 and solve for x. So we replace y with 0. So we got 0 equals 4,500 minus 300x. However you want to do it, you could add 300x to both sides, then divide by 300, or you subtract 4,500 and divide by negative 300. Either way, you're going to get 15. 15 what? Let's go back to what x means. X means minutes. In other words, it takes 15 minutes to reach the peak. When it starts out at time 0, it is 4,500 meters away from the peak because you're starting at the bottom and going to the top. So the distance away from is 4,500. Starts up there. And then to find, I just gave that one away. It takes 15 minutes to reach the top. That's when it's 0. I gave it away. To find the y-intercept, replace x with 0 and find the f of 0, the value of the function when x is 0. The f of 0, or again, this is your y at 0. You put x in there, 0 in there for x, 4,500 minus 300 times 0. Well, 300 times 0 is 0, so it's 4,500. In other words, at time 0, when the time is 0, you are 4,500 meters away. When the time is 15 minutes, you are 0 meters away from the peak, which means you've reached the peak. Okay, let's do one a little bit. Let's kind of work another one out here. A hot air balloon is 750 meters above the ground and begins to descend at a constant rate of 25 meters per minute. The function, per slope, okay? The function f of x equals 750 minus 25x represents the height of the hot air balloon after x minutes. Oh, there we go. We know what x means. We know when we find the x-intercept, we know that's going to be in minutes. In other words, this is how many minutes it takes to get to the ground. So if I'm finding the x-intercept, I replace f of x or y, it means the same thing, y with 0 and solve for x. So let's do that. Put 0 in here. I'm going to do one more step. I'm going to add 25x to both sides. So I get 25x equals 750. Divide both sides by 25. And you get 30. X equals 30. Yay! 30 what? Nose hairs? No, 30 what? What is the x-axis? What does x mean? X is minutes. It takes 30 minutes to get to the ground. That's a long trip down, in my opinion. It takes 30 minutes to reach the ground. So let's do the y-intercept part now. To find the y-intercept, you replace x with 0 and find f of 0, or y here in this case, right? This again, this is just a y. Replace x with 0, you get 750 minus 25 times 0. Well, 25 times 0 is 0, and you're just left with 750. Yay! Y is 750. 750 what? Well, just like we talked about, the hot air balloon starts 750 meters above the ground. So at time 0, at 0 minutes, it's 750 meters above the ground. And it takes 30 minutes to be on the ground. So you got to look at your two axes here. Okay. So the height above the ground when it starts is 750 meters. All right. A classmate says that the graph shows the path of the tram. Okay, so this is going back up to A. This one says it shows the path of the tram. Do you agree? And I've kind of alluded to this, or gotten to this a little bit. That does not show the path, because this is the distance from the peak. In other words, you start 4,500 meters away from the peak, and if I'm trying to go to the peak, I'm going to go up to the peak, right? So no. A classmate says that the graph shows the path of the tram. Do I agree? No. Why? Because it tells me how far away, the function tells me how far away I am from the peak, not the distance I actually am. The function tells me how far away from the peak I am. Not the elevation. Elevation. Okay. And elevation. In other words, what I'm trying to say is at time 0, I'm 4,500 meters away. That's what that says. And it's going to take me all those minutes to get up there. Here's your turn. I'll read it. The temperature in an experiment is increased at a constant rate over a period of time until the temperature reaches 0 degrees Celsius. The equation y equals 5/2 x fractions minus 70 gives the temperature y in degrees Celsius x hours after the experiment begins. Hey, look at there. Y means degrees Celsius. X means hours. There we go. I know you picked that up. After the experiment begins. Find and interpret the x and y intercepts. I gave you a little hint, so push pause. It's always so awkward. I hope you paused. Now you're going to come back and check your answer. I hope that's what's going on. Anyway, okay, so again, we're going to do the exact same thing we've been doing. Make this a little bigger so I can write down here. Okay, we have this equation right here. I know it's an equation because there's an equal sign. If I'm trying to find the x-intercept, the xint, I'm going to set y equal to 0. So I'm going to substitute y for 0, or 0 for y, equals 5/2 x minus 70. And I need to solve for x. X-intercept, set y equal to 0, solve for x. I'm going to add 70 to both sides. 70 equals 5/2 x. I'm going to divide by 5/2, but dividing by 5/2, I need to flip the fraction and multiply. So I'm going to flip 5/2 to give me 2/5. I'm going to multiply both sides by 2/5. 2/5. And now I need to simplify this fraction. Here we go. If I multiply here, 5 times 2 is 10. 2 times 5 is 10. That's just 1. It all simplifies to 1. It does not cancel. It's not a cancel. It's a simplify. Okay? So x equals, can I simplify here? Yep, I can simplify 70 and 5. This becomes 14 and 1. I multiply across, and this is 28. Yay, 28. 28 what? 28 what? What was X again? X hours after the experiment begins. So this right here means it took 28 hours for the temperature to get to 0 degrees. 28 hours to get to 0 degrees Celsius. 0 degrees Celsius. Okay. What does the y-intercept mean then? Let's go ahead and take a look at this. The y-intercept. I've got, again, y equals, so we'll do the y-intercept. I know I'm writing in a small spot. We'll see how this works out for me. Again, set x equal to 0, so I'm just going to do that. I'm going to do it right now in my head. 5/2 times 0 is just 0. So the y equals -70. Oh, interesting. In other words, my temperature was increasing. So if I said get down to, I should have said go up to, because the temperature's increased. The temperature starts try that again. At -70 degrees Celsius. So that's how we interpret that. Okay. Now, those are some tough ones, and that's okay. What I want you guys to do is go ahead. I've already given you some practice from the first one. I'm going to give you some more practice right now to look at. Make sure that you're checking your answers with the solutions guide. And after you've done that, you are going to need to turn these in, because I want to see what you've been working on. So let's go ahead and go to the practice and add to what we've done. We already had 1 and 2. We already had 3, 5, and 7. I want you to do 9 and 10. Ooh, let's see what else we got up here. I would like you to do 12. And then on the next page, I would love you to see you do 20 and 21. I think that's all I really want to have you do right now. Nope, just kidding. Just kidding. I want you to try out 23. Okay. So again, we'll start back here again. That was 1 and 2, 3, 5, 7, 9, 10, 12, 13, 12, 13, 15, 17, 20, 21, and 23. So if you have any questions, make sure to show up to the live sessions or set up a time with me using the Sign Up Genius, or send me an email. We'll go from there. Hope you guys are doing great. Take care. Have a great night.